Carlo Iorio. I hope I have pronounced your name correctly.
More or less. I hope that you can hear me.
Yeah,
but it's not so easy.
Yeah, thank you.
Too many vowels.
Yeah. So Dr. Carlo is a senior researcher at University of Brussels, Belgium, and is a team leader at the Microgravity Research Center in the same university. At present, Carlo coordinates 3 international networks on human space exploration on behalf of ESA, the European Space Agency. He is the coordinator of several parabolic flight campaigns as well as sounding rockets and ISS experiments. Recently, his main interest is about the development of a suitable lunar ecosystem capable to support the future human bases. He also provided consultancy for the major players in the industrial space ecosystem. He has been recently awarded the title of a Space Champion of the Graphene Flagship with the role of promoting the industrial exploitation of innovative materials in space. Today, we welcome him to talk on human space exploration. Sir, please.
Thank you so much, Chairman, and thank you for inviting me. I will try to share my screen, and I hope that you can hear me. Normally, now you should see my presentation.
Yeah.
Okay. So, really, I am happy to talk about space technology, but especially about the future of humans and humanity in space. Yesterday, as you know, there was the first launch of a probe towards Mars of the Emirates Space Agency, and so this is another piece of the puzzle in terms of the human space exploration. So I will give a talk that maybe is not so, we can say, strictly scientific, but I hope to give you an overview of what is happening in space and how exciting is this period for the human space exploration. So when you think about space, the first question I think that everybody is asked for is, but why we are going to space? And so there are different reasons for this. First of all, because space research is one of the most powerful driving force for innovation in technology. And this you can immediately understand why, because space is a very extreme and harsh environment. So basically, the challenge is in order to keep people in space, living in space, going to space, implies the development of technology, of science that barely could be seen in, we can say, challenges on ground. On the other way around, the possibility to develop technology in space will open up a series of markets that have the biggest return on investment ever. So, for example, I just recorded some figures in order to understand how and what is moving on in space. So the global space economy is growing at a very high pace, and the investment could be counted in the order of billions. There are venture capitalists, business angels, and everything is a bit, especially in the last years, is becoming more and more developed in terms of ideas. Everybody has followed the SpaceX launch recently. So space is opening up as we can interpret as a bigger Earth. So now we are expanding the size of our planet by doing technology and science even in an extreme and harsh environment that is more and more accessible for everyone. And just to continue to make understand, consider that from the beginning of the space era, more than 4,000 technology has been transferred to ground, not only for business, but also to help the manufacturing sector, the healthcare sector, and so on and so forth. So, just to have an idea only from the Apollo 11 mission. These are the technology that we are using all the day in our life and has been developed especially for space application. So, for example, the computed tomography scan has been developed by NASA as a method for enhancing lunar pictures, but also, for example, the cordless drills has been developed for the Apollo mission. Also, the sunglasses, so the UV blocking sunglasses, were firstly developed for space exploration. So we can say that from space you have big challenges, and these, of course, trigger the search for solution. That means that it triggers the search for new science, new technologies. And this is two examples. I think that everywhere now, telemedicine, artificial intelligence, machine learning is considered some sort of buzzword in the last years. But consider, for example, that the first application of telemedicine was during the NASA Gemini program in the 60s. So imagine how far away was the development in space of technology that only 40, 50 years later are becoming of use in everyday life. But we are not speaking only about high technology or solving very big challenge in extreme environment. I want to give you another example. So the precision farming. You know that everywhere in the world, agriculture and the use of pesticide or basically the scarcity of water are becoming a bigger and bigger burden for the development of a single country, and this is especially in a developing country. So precision farming, that is using the data satellite in order to increase the productivity without increasing the use of pesticide, to increase the productivity without using a lot of water that in some countries is very precious, is one of the applications that is allowed by space in general. So I want to give you back to, in order to introduce a bit of more scientific background, so the basics of space applications, and I am sorry if these are very, very simple concepts, but it's important first of all to understand what the absence of gravity is. So in general, what is called weightlessness is the condition experienced when you are free falling in a gravitational field. So please distinguish correctly between the mass and the weight. So you can see, for example, that on Earth we are a bit on the middle in terms of gravitational pull respect to other planets. So consider that the object is free falling. So how can you realize this? So if you remember, this was experiments in the beginning of the 19th centuries, so the equivalence principle. So imagine that you are on an elevator, and of course, if you weigh like 80 newtons, so if you are going up, you feel this force, this push toward the ground, and if you are going down, you feel like you are a bit losing weight during the descent of the elevator. And of course, you can realize in some way a free falling state simply by cutting, we can say, the wire of an elevator. So it was very immediate that the people begin to understand that, of course, you cannot just cut and have this free falling state. There should be another way to realize space conditions. And the first one was Newton. So basically the experiment, on the right you can see a reproduction of the original draft of Newton. If you basically fire horizontally, we can say, a bullet, and you can fire with enough speed and with enough momentum, at some moment in time you can realize a condition where the object is simply continuously free falling, and this means that in a more simple term is simply orbiting the space. And so this is the concept of orbits. So the orbit is a curved path that allowed an object, a body, to basically going circularly around a planet in a gravitational field and realize a continuous state of free falling. Now, of course, I cannot now go very deep in the different kind of orbits, but the two most important orbits I want to spot. So one is the low Earth orbit. The low Earth orbit extends up to 100, is a convention, but extends up to 1,000 kilometers above the surface of Earth, and we can say is where the humans are basically colonizing now the space. So it includes a lot of the satellite world, but includes also the place where there is the International Space Station, where most of the rockets that are using in science are fired, and so on and so forth. And then we have the geostationary orbit. You have heard for sure a lot about this. Is the position, the orbit that allow to have the same spot on the Earth always at the on site, so that this will allow, for example, for specific application in general for telecommunication satellite. So I just want to show you a bit of fun facts about the space exploration, so you can read by yourself. The first one, what I want to spot is about the baby giraffe, because this is one of the example where the observation of nature really were coupled with the high technology. So the point was that, as you possibly know, when you are in microgravity, blood is going up to your brain, and this create a lot of overpressure at the level of the eyesight. Sometimes astronauts feel also some hallucinations, feels vomits, headaches, and so on and so forth. So how to drain back the blood to the leg? So basically the idea came from exactly the same problem that was solved by nature with the legs of the baby giraffe. So, but as I told you, space is also a very big opportunity for scientific and technology experiments. So in this picture, I will show all the platform that we can use in order to do our own experiments, to test our own technology idea by using the space environment. So these are a bit a small overview of the different space and microgravity platforms that are allowed to be used to the international community, so including university from all over the world. So in general, we can say that the microgravity condition can be created using 5 main platforms. I think that in a following presentation, Dr. Yarjan will show also how we use this with the graphene experiments, with material science experiments. And so in general, you can list the platform in according to several criteria, but in general they are listed against the fact that they are manned, so there are really people that can do experiments and they are on board, or unmanned. The unmanned platform that are usually used for generating microgravity are the drop towers, the sounding rocket, or the satellite. And the manned platform are the Parabolic Flight and, of course, the space station. I put the space station, you see a picture of the International Space Station that so far is the biggest achievement of the mankind in the space exploration. Is a very big platform, the size of a football field, so it's quite high, but it has been preceded by other space station like the Mir station, the Russian Mir station, and it will be followed by other space stations like the Chinese one that will be launched in a couple of years' time. So just rapidly, drop towers, for what it is, it simply is a tower where you make your payload, your object, your experiments fall down in the ground. And this provides a very short microgravity time, like 9.3 seconds, but a very good microgravity quality, what is called the microgravity quality, that is the ratio between the microgravity level, so the gravity level during the experiments, and the gravity on ground. So 10 minus 6 G0 means basically microgravity, so few millionth of the gravity level on ground. And then we have the sounding rocket. So sounding rocket provides 6 minutes. So it's really a rocket that is launched. With the group of Yarjan in Cambridge, we recently launched a sounding rocket last year from Kiruna in the north of Sweden. And you can do a lot of different experiments. So you can do experiments in material science, so to test the composite. I followed the presentation of the professor before, testing composite. You can testing the formation of zeolites, colloids, or you can study capillary wetting phenomena, but also a lot of biology. So, for example, the protein crystal growth or self-organization of molecule, for example. And I want to show, please, be aware that it's quite noisy. I want to show a nice movie about the launch of the rocket, where the group of Dr. Yarjan and myself, we tested last year. So I think that it's very noisy, so please, I will try to reduce the sound. And so you can see this is generally how a sounding rocket is launched. So it is spinning at the beginning for keeping the trajectory, but a yo-yo mechanism is a very simple mechanical mechanism. Then stop the rocket, and it continues its parabola and generating 6 minutes of microgravity. So as you can see, this is also one of the proof that the Earth is effectively round and it's not flat. There is a lot of people speaking about the flatness of the Earth. I will accelerate a bit. So now this is the parachute. So I think that this is fascinating and inspiring, not only because you can produce good science, you can create technology to be tested, but also it's a nice environment for the students to test their own ideas and their own, and to improve their research. So what we have then? We have the CubeSat, so small cubes that are, we can say, the low-cost space utilization. So you can create your own satellite. Now there are more than 2,000 small satellites that have been sent in space, and you can do still a lot of kind of experiments by considering that it can last between 10 days, 20 days, and a very good level of microgravity. So you have the Parabolic Flight. This is another platform that has been used by the group of Dr. Yarjan and in Cambridge and myself in Brussels. And so in Parabolic Flight, basically you will use a plane to do a maneuver that reproduces an ellipse. During the top of the ellipse, you experience between 18 and 25 seconds of microgravity. Of course, it's not so much as a time of microgravity, but still you can, for example, study transient phenomena or the aggregation of some structure, and especially can be used for increasing the knowledge about what will happen in space and in science. So this is a typical maneuver, but I don't want to spend so much time on this. For what concerns the satellites, this is a bigger flying saucer. So again, this is another platform. You can study whatever, because it can durate up to 12 months, so it's very long duration. So imagine about the biological experiments that needs a lot of time in order to allow the cell to divide and to do adaptation of the genes. And then as a last platform that I want to talk to you today is the International Space Station. So the International Space Station is, we can say, as I told you before, the biggest achievement of humans in space environment. You can have on board, you have different kind of laboratories where you can study the colloids, foams, you can study plant biology, you can study the rhythm, the circadian rhythm of the people, you can test the bioprinting, for example, now the generation of organoids, material science of whatever kind. For example, now there is a printer in space with graphene and different kind of material, and of course the time is very long, so you can go up to months. In general, the International Space Station can allow you to perform experiments even in the order of years, but it depends, of course, on the time of the astronauts to do that. So another stuff is the new era, the small satellite. This is very good, I think, as a training platform for students, because you can create your own satellite, so you can take advantage not only of your knowledge, scientific and technology knowledge, but you can also understand how to put together a complete experiment to be fully controlled by outside. So, which is the future of exploration? And so now we have basically colonized the low Earth orbit, and this is why now commercial exploration begins. But as you have possibly heard on the news, now the frontier of exploration is going basically to the moon. And then it will go in 15, 20 years time, possibly to Mars. At the same time, we are launching probe. So basically, the future of exploration in space is very bright. I don't know how much time is left, because I want to just give you
Carlo, last minute.
Okay, so I will stay on this. So what we can do, so which is my message? The message is that you have to think about space as a platform, as a laboratory where you can do experiments that in general you cannot do on ground. Consider which are the phenomena that the absence of gravity basically imply in your own experiments. So I don't know, I saw before the presentation you were speaking about membranes, about fluids. So imagine where fluids where the surface tension, so the droplets, are not influenced by microgravity, where the surface tension will become much more important than the influence of gravity. Imagine a flow where the diffusion, because you can have a pure diffusion, the diffusion becomes more important than the convection, that often, as you can see, masks phenomena on ground. So, for example, diffusive states bring immediately to the creation of a highly pure crystal, because you don't have the convection that break out the order. So you can study better, for example, photonic crystal, better aggregated structure. Even when you have no sedimentation. So it means that you can test mixture of materials and elements that are not basically superimposing by density one on the other, but they can be mixed up and giving much better properties. There is no hydrostatic pressure. So look around at your experiments and consider what maybe you have never noticed before, even doing mathematical modeling, how many times you have put the gravity term, the hydrostatic pressure, you have considered the convective terms in heat and mass transfer. But now imagine an environment when you can refine everything, you can get rid of this, and which can be the consequences for your experiments, not only for the space exploration, but also to better understand what is going on ground. So there are a lot of platforms. We are using it in Belgium. We are also available for collaboration, even in Cambridge, that are our fellow partner in many of European Space Agency program. So take advantage. If you have your experiments, think about, oh, maybe I can use this. Maybe I can generate technology, because the space, we can say our planet is becoming bigger and bigger, and this is a good for humanity, I think. Thank you for your attention.
Yeah, thank you very much for such a wonderful talk, especially for letting us know the basics of human exploration, the issues, and also something relevant to the small projects that we can do here on Earth. Let's go to the audience for a question. Zebun Nisa.
Thank you.
Zebun Nisa, please turn on your mic. Zebun Nisa. Zebun Nisa, can you hear me? Okay, let's move to the next audience. Arshad Ali.
Hi, can you hear me?
Yeah.
Yeah.
Okay. So thanks for the talk, and my question is about asteroid mining, because you know the resources on Earth has already been depleting, especially for rare earths, which is the main component of the modern devices. So, what you think about the asteroid mining? Because there are some companies where they're looking for investors to do this idea into a reality. So, I just want to know your thoughts about it.
Thank you. So I tell you the truth. It will not happen very soon. So it's not a question of 1 to 5 years. Still, we have to consider that it will happen. So consider that for what is the technology advancement, we will go to space, and when we will go to space and on Earth, we will need more and more materials, but also on Earth. It's not only a question of depletion; it's a question that our world will change. So at one moment in time, some of the manufacturing that we are doing now on Earth will be much easier to do in space and to recover materials in space, especially for we can say the pollution, to take about the environment. So it will happen one day. What is really important is that although the day when it will happen is a bit in time, the point is that it's very difficult to think about the technology. So it's still meaningful to start now to understand how I can do an excavator. I don't want to speak about only big science, because when you are in space, for example, the suits of the astronauts or the robots. Robots, when you are in space, should withstand radiation. This is not a problem that we have now, because hopefully we are protected by the magnetic field, essentially, of Earth. But what about when you even are robots and electronics? So, for example, speaking about graphene has been used as a shield for electronics against radiation. So it will happen for sure. This is stuff. It will help both us on Earth and possibly our colony in space, but essentially will push us to develop a full set of technology. We should think about space as a new ecosystem that we have to create. It was very interesting, the talk before about the membrane filtration of water, because sometimes we have on Earth places that are desertic, that are remote, and so on and so forth. If you think about, this is exactly what we have in space: scarcity of water in a desert land. So basically, what we are doing on ground can be used in space, and what we develop for space can be get better the life on ground. So my question is, yes, it will happen, and it will be good.
Thank you.